Is the speed of light, Paul, different in space and a vacuum? Does it not travel faster?
When we're talking about the speed of light, what I should have said is the speed of light in a vacuum. Now, light going through glass, for example, goes about 30% slower. Light going through water, no, probably 20%. There you go. Light going through other things slows down. It never speeds up. So the speed of light in a vacuum is the fastest it can go, and that is believed to be a constant.
And the definition of light here is a fixed point on the electromagnetic radiation
spectrum. No, a light
spectrum.
year is just a distance.
It's distance.
Right? It is how far light travels in a year. Okay, a light year is a distance. It's so many yards, so many miles. What astronomers actually talk about is parsecs and megaparsecs, which is related to astronomical measurements of distances. And there, if I recall correctly, a parsec is about 3 light years or something. But a light year is simply, it's not a time, it's a distance. Okay? It's a convenient way of, because the universe is so big, it's easier to say it's 10,000 million light years than to say it's 1,000 million meters. That's all.
But the light itself has to be a point on the spectrum.
Well,
no?
I say light, I'm talking about the speed of light. The speed of radio waves is the same as the speed of light waves, is the same with the speed of microwaves. They all go at the same speed.
They all go at the same speed.
So
that's great. That answers that question.
Okay, we call them light, but it could have been X-rays or gamma rays or radio waves or microwaves. They all go at the same speed.
That answers that. That's
okay, so we could talk about a microwave year.
A microwave year, right. Brilliant.
if you wanted to.
Thanks.
Okay? I welcome interruptions, by the way.
Paul, just can you clarify when you talked about flat geometry?
Yep.
I must be missing something because it sounds obvious to me that, of course, if you're measuring the distance between here and Mars, that there's nothing between us and Mars. So why would it be spherical? Why wouldn't it just be straight or
Indeed. Euclid had a thing called the parallel postulate. He said one of his fundamental axioms on which he built his geometry is that if you take a straight line and then a point which is not on that line, there is only one line that goes without meeting this line. Do you follow me? Mm-hmm. This is a parallel line. Now, people say, well, that's obvious. You can prove it, can't you? Well, you can't prove it. Euclid was quite right. This was an axiom. He said, let us suppose this is true. There's only one parallel line to this line. Now, other people subsequently discovered other kinds of geometry. In some geometries, there's thousands of lines that don't meet this line. They're corresponding to the saddle-shaped geometry. In other things, there are no lines. They all meet, like lines on a sphere, on the Earth's surface, they all meet up. Okay? Now, the real geometry of space, I think that Kant thought that geometry was one of the things you could prove by pure thought. That you could prove that Euclid's geometry must be the geometry of space. Well, he was wrong. There are other possible geometries of space. And it's now an experimental matter to discover whether space is Euclidean or not. Does that make sense? Now, it's pretty closely Euclidean. The geometry of the solar system is very accurately. You haven't got to worry about your theodolite not being quite right, because the angles are pretty... But when you get out to the scale of the galaxy, the galaxy is still Euclidean. You have to go to the edge of the universe before you could get any possible effect. And even there, we think it's pretty close. That makes sense? But it could have been, the mathematics of spherical geometry is well understood. So it's quite possible to do mathematics in where Euclid isn't true. What we're saying is experimentally, our universe, Euclid is pretty close to being true.
Well, would that be true even at the very small scales around the black hole? Because space is warped.
You're quite right. I said before that we also talk about space-time rather than space, so it's more complicated than that. But yes, in a black hole, gravity curves space, and close to a black hole, you definitely get big effects.
Well, the point I was trying to get at the speed of light.
Yep.
There's a certain value in a vacuum. Say God set the universe in motion, but he picked that specific speed as being the only one to work, or could he have chosen a different speed?
Right. The answer is I don't know. But the speed of light is measured in terms of other things. You know, you need a ruler of some sort. And actually, the ruler is made of atoms, and the structure of the atoms also depends on speed of light and whatnot. So it's very hard to know where to stand. I think probably I can't make a very useful answer to your question. Sorry about that. This week and last week you described for us many coincidences which you feel point to a design and a designer. Which of these or others have been most powerful in convincing you that there is a designer? Or are there other truths or evidence that influence or persuade you that there is a God? I'm going to say more about this next week, so I won't go deeply into it now. In my own experience, I did not study physics and the universe and whatnot and come to a conclusion, oh, there must be a God. I became a Christian as a child, and subsequent to that, I had all sorts of doubts. So it's a complicated process as to why I believe there's a God. And I actually think that the fundamental reason why I and most people believe there's a God is revelation. In other words, God has made himself known to us. He has revealed himself. So it isn't that we worked it all out. It is that we, in one way or another, he communicated to us the fact that he was real, through parents and through experience and through the Bible and so on. And then you say, well, how does this actually fit in? So for me, it's been very encouraging to see these evidences of design and say, well, actually, that does fit in with what I believe. But it wouldn't be true to say that's the way I came to believe in God. I do find, I mean, as a scientist and a Christian, I've been troubled by a number of the challenges to Christian faith from science, okay? And I find them bothersome, and I still do. There are things that I can't, in my own mind, resolve properly. But to me, it is very encouraging that there are these other things. These sort of, golly, this looks as though we are supposed to be here, you know? There are these things which atheist scientists find very embarrassing. Well, I don't find them embarrassing. I say, well, that's just what you expect, you know, if you're a Christian. I'll say more about that next time, if I may. Is the fine-tuning for life to exist depending on so many factors there is unlikely to be life anywhere but on Earth? Well, two parts to that. We think that the laws of physics are the same throughout the observable universe. They're the same here as they are on the Andromeda Nebula and on the far side of the universe. So in a sense, the laws of physics and the history of the universe that make life possible are, we think, the same everywhere in the universe. So from that point of view, if life is a natural phenomenon, it could occur anywhere, right? Now, in addition to that, there are a series of remarkable features about the Earth which make it a very special place. You know, being the right distance from the sun, having plate tectonics, you know, all sorts of things which make the Earth a very special place. And therefore, to actually assess whether there's elsewhere in the universe where life could happen is very, very difficult. It's not so obvious as you think. And then, the whole question of the origin of life is a scientific conundrum. I think it's right to say, and I'm not an expert in this, I think it's right to say that no one has a clue how life actually started, in the sense that the problems of putting together a cell and DNA and RNA and proteins and all the rest of it by chance are enormous. And therefore you may say, well, you know, the chances of life starting are minuscule. From a Christian point of view, you may say, but if life was always part of God's plan, hasn't he made the elements and the laws such that life is possible, and therefore life could be existing elsewhere as well? This is a bit outside our sort of field of view for these lectures. I don't think it's a necessary Christian point of view to say there ain't life elsewhere in the universe. I think it's an open question from the Bible. I think it's an open question from science. And so I don't think that we have a huge sort of say we've got to prove there's no life elsewhere in the universe. But I think the laws which I've been talking about which make life possible are, we think, the same everywhere. The conditions that make life possible on Earth may be very, very special. And I think it's probably true to say most biologists are much more astonished by the series of extraordinary coincidences that seem to have made life possible than most physicists are. But I'm out of my depth here. So I don't think that Christians have a huge prior... No, we shouldn't be saying there can't be life elsewhere. Well, maybe not, you know. God does all sorts of interesting things.
Well, as a very small child, I always used to try and imagine the picture of God in my head. And because I believed in life elsewhere, I always imagined him as having... he wouldn't be fully human in picture. He would be part other aliens.
Right.
Other
That's
creatures
interesting.
and things.
That's very interesting. Thank you. Thanks. It's 9 o'clock. We probably want to stop. What do you think the purpose of antimatter is?
Can I just ask
Yeah.
about dark flow?
Dark.
Dark flow.
Yes.
Have you heard of that?
Well, I know that dark matter is well existed, and there's some evidence that it moves. Is that what you mean?
I'm not a great fan of the Big Bang theory, but I'm interested in this idea of dark flow. This idea that if there was, because there were some astronomers from Russia recently who did various, they spent a year, and they found this anomaly in space which seemed to show that dark flow existed.
I think this may be what Ian was mentioning, there's a strange attractor. There are sort of areas in space which seem to attract things.
But the idea, from my point of view, what I was thinking of was this idea that if you had a stream and someone was to come and sort of dig a spade in and pull it open, then the universe would sort of flow out. And that would account for your expanding theory, but get rid of the Big Bang theory and replace it with...
You're not happy with the Big Bang?
Not happy with Big Bang, but I like the idea of dark flow. I think it's, it gives the mystery is still there. We always like to sort of define a beginning and that type of thing. And I like the idea that we don't know that.
What I would say is that scientists should be open to all new ideas and not to think we've got it all buttoned up and there's no mystery, right? On the other hand, ideas need to be quantitative and able to make predictions before you can assess them. And a number of the ideas that people have had, when they've worked them out as actual theories, they can be disproved. Someone was talking, for example...
In a way, death isn't, though, something that you can quantify in that way. Yeah. And if that's all part of it all as well, then, you know...
I mean, I've probably been in danger of being too dogmatic and saying, this is all definite. I am impressed by the way, and I say, it's only in the last 10 years. You know, I couldn't have given this talk 20 years ago with anything like the confidence I've given it tonight, because of the amount of experimental evidence that is now sort of, you know, the observations that are all fitting together. I mean, I'm happy to go on chatting, but I think we should probably stop this now and then continue discussion in smaller groups so that those who need to go can go. And a sort of a health warning, next week may be a bit harder.